All right, challenge activity 6.2.2. There's a typo. An automaker is interested in information about how long transmissions last. A sample of transmissions are run constantly, and the number of miles before the transmission fails is recorded. The automaker claims that the transmissions can run constantly for over 150,000 miles before failure. The results of the sample are given below. So we are given the results here of I'll think of it in a second, of the hypothesis test. So we basically got your p-value and all that. So let's go ahead and take a quick look. First, let's see where our t-stat is. We're given at 1.889. And right here, we're given, it's a one-tailed test because they're saying that it runs over 150,000 miles before failure. We see this shaded region here, and we're given this one-tailed p-value test of 0.033. And it's easy to tell what that is also because it tells you we're looking for when that t is greater than or equal to the big T. But it's also a very small number, 0.033, and we're looking at this very small shaded area. If we were confused and subtracted that from 1, like thinking it should be the other way, that number wouldn't make sense. I'm going to type in that 0.03, so that's our one-tailed test right there. What condition is met for the t distribution? Says the population is stated not be skewed, which we weren't talking about, but the sample size is larger than 30. Look right here, our number of observations is 44, so we know we've met that condition. All right, n, as we just said, is 44, that's the observations. X bar is given by the mean right here, 151.2. Degrees of freedom, remember degrees of freedom are n minus 1, so that's 43. And then the sample standard deviation. Now remember, our variance is our standard deviation squared. So what we need to do is just take the square root. And if you don't have a calculator, the easiest way to do that is say square root 0.22, enter, and we get 4.15, what is it, 4.149 or 15, because once you round that up, so 4.15. Again, the standard deviation is the square root of that variance. All right, let's check. Nice little green check mark. Let's move on to the next section. We're still looking at the automaker. Let's see. So here we're looking at what is the level of significance. Well, we're given the confidence level is 95%, so that means our level of significance is 0.05. What is the null hypothesis? Remember, the null hypothesis in this case is always that the mean is equal to the value, that test value that we're looking at. So it's that the mean is equal to 150,000. The alternative hypothesis, so it says the automaker claims that the transmissions can run constantly for over 150,000. So that means we're trying to test to see if that mean is greater than 150,000. And then should H naught be rejected, or does H naught fail to be rejected? And I want to point out, and I've mentioned this before, but notice it doesn't say that do we accept H naught. We never say that the null hypothesis is true. We either say that it's rejected or it's not rejected. So that's an important distinction. All right, so let's look at our p-value is 0.033. Remember, if the p-value is less than alpha, our significance level, then we reject the null hypothesis. Our p-value here is 0.018, and our alpha is 0.05, so that means that we should reject the null hypothesis. So, what conclusion can be drawn from the data? Convincing evidence does not exist to conclude that the mean life of the transmission is over 150,000 miles, or convincing evidence exists to conclude that the mean life of a transmission is over 150,000 miles. Well, since we rejected the null hypothesis, this is what we could conclude. What is the 95% confidence interval for the mean of the transmission? So now we have this confidence level. This is actually our margin of error, that 0.665. So what we need to do is that we need to find our lower bound, and we know that that's going to equal our mean, which is 150.7. That's from right here. And we're going to subtract that margin of error, that 0.665. Then our upper bound is going to equal that same thing, except now we're adding them. Again, we're going to take 150.7, and we're going to add that margin of error. Oops, 6.5. All right, so let's go ahead and put those in. We have 150.035, 151.365. And then it says, does the confidence interval support the results of the hypothesis test? Now, I'll be honest, I don't typically recommend using a confidence interval for a one-tailed test. It is a little bit more confusing, especially because we're not accepting the null hypothesis. However, in this question, it is asking for that. And there is a way you can translate the confidence interval for the test. I just want to caution and be very honest. You really should only use a confidence interval to make conclusions about a two-tailed hypothesis test, not a one-tailed. In other words, not a left or right-tailed test. But we will go ahead and go through with this for the purposes of this exercise. The fact that 150,000 is not in our, or excuse me, 100, yeah, yeah, because, okay, so the fact that 150, because remember, this is in thousands of miles. The fact that 150 is not in this confidence interval means that we do not think it's likely that the mean is equal to 150. Remember, this right here, this confidence interval, is our estimation of the population mean. And notice it is positive and there's no 150,000 there. It's all above 150,000, which does support our hypothesis test results. And it says why? It says the hypothesized mean falls outside of the bounds of the confidence interval or it falls within. Well, we just said it falls outside. So that is why it supports that finding. But again, I do caution you against using the confidence interval for a one-tailed test. It can be a little more confusing than using it for a two-tailed test. All right, let's check our answers. Green check mark. Let's go to part 3. Worker stands at the end of a production line for mint chocolate chip ice cream. Oh, that sounds good. And uses warm water to melt the ice cream away from the chocolate. The amount of chocolate is then weighed. Each container should contain 4 ounces of ice cream. The results of a simple random sample of 12 containers is shown below. Assume the amount of chocolate added to the ice cream is normally distributed. That's an important point because that makes our conditions, at least one of them, is met. So which condition is met for for use of the t distribution? Well, the population is stated to have a normal distribution. The sample size is smaller than 30, but we are told that it's normally distributed, so we can move forward with that. The level of significance, remember, if we convert this to a decimal, we get 0.95. 1 minus 0.95 gives us 0.05, so that's our level of significance. What conclusions can be drawn from the table? So, we're going to say that sufficient evidence does not exist to suggest the mean amount of chocolate in the ice cream is not 4 ounces or there's not sufficient evidence. Now, just to point out, when we're thinking of this in terms of a hypothesis test, remember, our first null hypothesis would be that the mean is equal to 4. Now, it doesn't say if we're testing to see greater or less than. We're just trying to see if it's different than 4. So that means it's a two-tailed hypothesis test. So that means we're going to come down here to the two-tail and we're going to get our p-value from right here, which is 0.029. Our alpha is 0.05. That means we reject the null hypothesis. When we reject the null hypothesis, we say there is sufficient evidence to support the alternative. So we would say sufficient evidence exists to suggest that the mean amount of chocolate in the ice cream is not 4 ounces. All right, what is the confidence interval for the chocolate? We're going to come over here again. We have our lower and upper bound still. Remember, we have our mean, that's 3.808, and we're going to subtract that margin of error down here. That's 0.168. And then for the upper bound, we're going to do the same thing, but we're going to add 3.808 plus that margin of error, 0.168. All right, so let's put those in here for our lower and upper bounds. We have 3.64 and 3.976. And then, does the confidence interval support the results of the hypothesis test? Now, this is more in line with what I was talking about with using it for a two-tailed test. In this case, we were looking to see if 4 is in the interval here because we're trying to see if we think that the population mean is 4 or not 4. And we don't see 4 here. And we did say that there was sufficient evidence to say that the mean amount of chocolate is not 4 ounces. So when we don't see 4 here in that confidence interval, those agree. So we would say yes. And then the reason for that is that the hypothesized mean falls outside of the bounds. Let's check our answer. Nice little green check mark. All right. So if you have any questions about challenge activity 6.2.2 or anything else, let me know.